So basically, this is the current definition or one of the definitions. There are at least three, if not four. Actually, at the moment, there are about six definitions, because there's one or two new committees on nomenclature that have popped up around the world. The International Fascia, the International Associations of Anatomists have their own committee on nomenclature, but others have also. And so there just doesn't seem to be any great agreement in regards to what fascia is and what fascia is not. Do you want to say anything there while I rescue my throat? Sorry, guys.
Well, yeah, I have, obviously I'm right with you on the bone is fascia. It has to be, because it begins as cartilage that becomes bony or harder soft matter as a result of forces moving through it. And that's basic embryology. That's not complex. And what I get very frustrated about, and I wrote to some of the head people at the board of nomenclature that you're referring to and said, can you tell me why bone isn't fascia? We know, for example, fascia is connective tissue, blood is connective tissue, and we accept that blood is discussed under a different biological heading of developmental biology and so on, but it's still accepted as a connective tissue. And I got a reply that basically said fascia is designated as continuous and bone is discontinuous, therefore bone cannot be fascia. And I think that really highlights the real semantic and literal problems that you have of seeing a tensegrity that looks like this, as if this represents bone and this represents any other soft tissue. And what you're basically saying is these are therefore disconnected, so they can't be like this, and this is fascia and this is bone, and they're different. And anatomically, and I'm not a clinical anatomist, but I've spent an awful lot of time in the lab. And there is no separation between soft tissue and bone. It's not just that the periosteum, the outer sheath of the bony material, is like a membrane in that video. It's not like a membrane. Its fibers are deep into the bone. It's just like the skin and the skin ligaments into the subcutaneous tissue, and the attachments between the myofascial so-called units. There's this angled integration into the whole body that just keeps going in. Is it Sharpie's fibers?
Sharpie's fibers, yeah.
Yeah, of the periosteum into the bone. And when you look at the embryo and you imagine that the pelvis is pretty much a ring of cartilaginous material until the baby starts to move and starts to put forces through it, and we'll talk about this more in the next one when we talk about embryology. And those forces transmit an organizational pattern, as we've been talking about, that starts off cell by cell, but they close pack. Instead of in a very loose, open way, they close pack in a very tight, dense way. And so those force transmission processes form bony integrations between the tensional tissues. But that's not in this shape. This is just a representation of the two forces of tension and compression. It's not a representation of form. It's a representation of force. And this is a distinction that is very poorly made and even more poorly understood, even at the highest levels of those designated to name the tissues. And as long as we treat bone as if it's different, it's like having factions in the body. How can it be different? It emerged from within the same embryo at a later stage of its development, surely.
Well, if we just feel the rim of your ear, that is cartilage. And if you feel the tip of your nose, that is cartilage. And if you were able to see the tissue between your bones, that's cartilage. But if you touch the tissue that's just lateral to the sternum in your chest, that's cartilage. It feels quite hard, but actually it's very, very soft. In dissection, you can cut through them with the scissors. They're very, very pliable and soft. So, and this is bone. So bone comes in different levels of softness. And simply that's because it's fascia, but it has, a different set of cellular deposits. So it's different to the fascia that we have here, which has muscle fiber deposits. Bone simply has calcium deposited within it, so it stiffens it. So, as I say, the argument there is that we really just have different, a continuum, one lamina, one matrix, one mesodermal tissue, which then specializes in stiffness, specializes in hardness. And in fact, as Horace and Stupak, Horace Wilde and Stupak, but Horace and Stupak in particular, have demonstrated that you see the cells arranging themselves depending on the amount of compression or tension that the cells are under. And the more compression a cell is under, then it becomes stiffer and harder and more bone-like. And the more tension that the cells are under, then they become more like tendons or gasters, muscle bellies, or softer